Similarity and applying properties of similar triangles. Remember what it means to be similar. Similar triangles have congruent corresponding angles and their corresponding sides are proportional. The easiest way to tell whether two figures are similar is that the two angles have to all be the same. They all have to be congruent. In a triangle, though, we actually don't need all three. We only need two of them. The reason for that is because if two angles are congruent in two triangles, we know the third angles are congruent. That's called the third angle theorem. Think about why. If two angles are congruent in two triangles, I know in each triangle, all three angles add to 180. That means that third angle has to be the same angle in both of those triangles because they both add to 180 degrees. You'll see example below. But all I need are two angles because automatically, if two are congruent, they're all three congruent. This is called angle-angle similarity. Look at the triangles at the bottom of the page. Are these two triangles similar? That's the question. Look at the big triangle, triangle DEC. Notice the 90 and the 60. I can subtract from 180, 180 minus 90 minus 60, and that means this angle right here is going to have to be 30 degrees. Look at triangle ACB. This angle right here is going to be 180 minus 90 minus 60. Again, it's going to be 30 degrees. I can see that all angles are congruent in both triangles, but I didn't really need to find that third angle. Yeah, they were both 30, and yes, they're similar. All I need are two angles, the 60 and the 90, the 60 and the 90, and I automatically know the third angles are congruent. These two triangles then are similar by angle-angle similarity. Take a look at these two triangles. If angle A was congruent to angle D, and angle B was congruent to angle E, I automatically know the third angles are congruent because if two angles are congruent in the two triangles, then the third angles are congruent. These two triangles are similar by angle-angle similarity. Remember, when you write a similarity statement, the order you write it in matters. You must line up the congruent angles. Triangle ABC is similar, and A is congruent to D, so they both go in the first spot. B is congruent to E, so E is second, and C is congruent to F. And then, because those two triangles are congruent, their corresponding sides are proportional. I know that AB, the first two, is to DE, the first two. AB and DE are proportional. I know that BC, the last two, and EF, the last two, are proportional. And the outside two, I know that AC is to DF. Take a look at the two triangles and look at the sides. AB is to DE as BC is to EF as AC is to DF. From similar triangles, we get a property. It's called the triangle proportionality theorem. I want to show you where it comes from. The first thing you need to have to use the triangle proportionality theorem is a parallel line inside that triangle. In this case, DE and BC are parallel. D and E do not need to be midpoints. They just need to be parallel, that's all. Now, I'll point out that this angle and this angle are corresponding angles. They're congruent. And this angle and this angle are corresponding angles. They're congruent because of the parallel lines. Those two triangles then, the small one above and the big one, small one within the big one, they're similar by angle-angle similarity. So I could say that triangle ADE is similar to triangle ABC. Now I labeled the sides in blue there, A, B, C, and D, just to show the property and where it comes from. If I use similar triangles to make proportions, it would be A is to, a lot of students want to say B, but that's not from similar triangles. You line up corresponding sides. And this side, that A, corresponds with this whole side here, which is A plus B. And this length, the C, it corresponds with this side right here, which is C plus D. So from similar triangles lining up corresponding sides, I get A is to A plus B as C is to C plus D. If we cross multiply, we take A times C plus D and C times A plus B. Those two things are equal. Well, let's distribute. AC plus AD equals AC plus CB. Notice how each side have AC on them. We could take off that AC from each side, and I get AD equals CB. Now let's make this in a friendly format so we can observe the property. Let's divide both sides by B. That'll cancel those B's. And let's divide both sides by D. And that'll cancel those D's. And we get A over B equals C over D. Now look at the picture. You might have thought that at the beginning, and you were correct. It is true that A is to B as C is to D. We can use this to solve questions. Sometimes it's a little bit quicker. Instead of going right to similar triangles, if we have that parallel line in there, it makes similar triangles. And in that case, we can jump right to this. A is to B as C is to D. As I said, that is called the triangle proportionality theorem. If a line is parallel to a side of a triangle, intersects the other two sides, then it divides the two sides proportionally. AE in the picture is to EB as AF is to FC. And we can state this a little more simply by just labeling the sides A, B, C, and D. This is the case that A over B equals C over D. To use the triangle proportionality theorem, it's just like similar triangles. You need to know that you have the sides parallel, so this one is parallel to that one, and then you can just make your ratios. 23 is to 15, as 18 is to x, and we'll cross multiply. 23x equals 15 times 18, and 15 times 18 is 270. 23x is 270, and then we can divide by 23. And the instructions, I believe, in WAMAP are to round to the 10th on this question. So we'll just divide that by 23, and to the 10th, x is about 11.7. The rest of this video is just answering questions from your assignment. Question 1. Can you determine whether triangle ABC and triangle DEC are similar? Well, I do have vertical angles here. That's helpful. Look at the parallel lines. Angle D and angle A are alternate interior. They're between the two parallel lines. You have to use your imagination here. These lines continue. And AD is a transversal. and those two angles are on alternate sides of the transversal. These two angles are also alternate interior angles. I definitely have angle-angle similarity. All I need are two angles congruent in two triangles, and then the triangles are similar, because I know the third angles are congruent. So yes, those two triangles are similar. Question 2. Are triangle ABC and triangle ADE similar? We have a right angle. We know that those two angles are congruent. That means that these two lines are parallel because two lines perpendicular to the same line are parallel, which means that these two are corresponding angles. And by the way, triangle ABC, that's the smaller one, and triangle ADE both share an angle. That's a reflexive property. It's in both triangles. I definitely have two angles congruent. I have angle-angle similarity. Yes, they are similar. Question 3. Can I determine whether triangle ABC and CDA are similar? They share a side. I have an alternate interior angle right here. We have a problem. We do not have these two parallel. We don't have this. You might jump to the conclusion that this is a parallelogram, but remember the reason something's a parallelogram. I could have opposite sides congruent, opposite sides parallel. I only have one set here parallel. Diagonals bisect each other. I could have one set of sides congruent and parallel. I could have one angle supplementary to both of its consecutive angles. I don't have any of that stuff. This is all I have, an angle and a side. That's not enough. The answer here is no. Not enough information. Question 5. Are these two triangles similar? We could call this angle X, and we know that 45X and this 90 here add to 180. Essentially, I could subtract from 180. I could find X by taking 180 minus 90 minus 45, or you could have said that X plus 45 plus 90 equals 180. Either way, if you solve that, X is going to be 45 degrees. We'll put in the 45 right here. Now I could find this one. I'll call it Y. I know that that's 180 degrees. And Y plus 92 plus 45 equals 180. Or I could just take 180 minus 92 minus 45. And Y is 43 degrees. So let's erase that Y and put in 43 degrees. Now you could find this angle up here by subtracting from 180. 180 minus 90 minus 43. 180 minus 90 minus 43 is 47. And those triangles aren't similar. I don't have two angles congruent. I only have one angle congruent, the 90s. The answer is no. Question 9 is a really quick one. They're telling us that these two triangles are similar. Hopefully they're giving us things in the right order. I know that I, that angle, is congruent to O, the angle, if they've stated it in the right order. And we're trying to find W here, and there's I. It corresponds with W degrees. And here's O, it corresponds with 117 degrees. Those are congruent angles as long as they stated the congruence right, and they did. W then is 117 degrees. This looks a little like the triangle proportionality theorem, but be careful, they did not tell us that these two were parallel. We don't know that. But we do know the two triangles are similar. That will be given. I will add that to this question. I see that the person that wrote it didn't. Line up the corresponding sides. In the big triangle, X corresponds with 18. Now you need to go back to the big triangle. The side we have is the 72 in the big triangle. A 72, and it corresponds with this small side here, 16. We'll cross multiply and solve. 16x equals 18 times 72, and divide by 16. We could divide these both by 2, and we get 9 and 8. 8 and 72 both divide by 8. If I divide by 8, I get 1 and 9. So look at that. X is 9 times 9. It's 81. Question 16. We're given those right angles. That means we have parallel lines because two lines perpendicular to the same line are parallel. This line is parallel to this line. So these two angles right here and here are corresponding angles. They're congruent. Plus those two triangles, the big one and the little one, share that angle there. So we have angle-angle similarity. Line up the corresponding sides. We can say that 15 is to 25. Now I'm going back to the small triangle. I started with the 15. Of course, you can start with either one, but if I start with the small triangle, then over here I have to start with the small triangle. As x is to 55. That's the side in the big triangle. Cross multiply. 25x equals 15 times 55. I'll divide both sides by 25. I can divide by 5 and I get 3 and 5. I can divide 55 and 5 by 5. I get 1 and 11. And 3 times 11, x is 33. In question 21, they tell us the triangles are similar. They've marked the angles. We know that these two angles are vertical angles. So that tells us that V is 30 degrees. We know that 30 W and the measure of angle E is 180. What we need then is E. Well, look, E is congruent to A. They've even marked it. And we can tell by looking at the similarity statement. See how E is first and A is first? So I know that E is 104 degrees. 30 plus W plus 104 is 180. That's W plus 134 is 180. We'll subtract 134 from both sides, and 180 minus 134 is 46. W is 46 degrees. We know that E is 104, which we didn't have to find. W is 46. We need V, X, and Y. V was a vertical angle. It was 30 degrees. Let's find X. The way you tell which sides correspond is, of course, you can look at the similarity statement, but if you've marked your angles, you can tell that way too. I marked the 2 as 30. I know that angle B is congruent to angle D. Now, between the 104 and the 30 is the X, and between the same two angles and the other triangle would be the corresponding side. And this was the 104 here. They're even marked congruent. Between the 104 and 30 over there, it is 20. X is to 20 as, and we go back and grab a side. How about 49 in the same triangle the X is in? It's between this angle, the 104, and B. And between those two same angles, the 104 and the one mark with two marks like B is 28. If that was confusing, let's look at the similarity statement. X is AC. Do you see how AC are the outside two? That corresponds with the outside two EC, that was the 20. Back to the same triangle with the X. BA or AB, that's the first two. It corresponds with ED, the first two, and that was right there. And that was the 28. So we can cross multiply. 28x equals 49 times 20, and divide by 28, and x will equal, I'm just going to punch that in the calculator, and you get 35. Let's point out you really don't need a calculator. You can divide by 7, and you get 7 and 4, and divide by 4, and you get 1 and 5, and 7 times 5 is 35. Now let's find y. Y is DC, that's the last two. It corresponds with BC, which is the 56. Y is to 56, as and I need two lengths that will work with me. I have to go back to the triangle with Y in it because I started with Y. I'm going to grab the 28, and I already figured out that the 28 corresponded with the 49. So we cross multiply and get 49y equals 28 times 56, and divide by 49. We'll divide by 7, we get 7 and 4. We'll divide by 7, we get 1 and 8, and 4 times 8 is 32. Y is 32. Question 24 is like the last one, just a lot less work. We're only finding y here. CD, that would be the last two. It corresponds with the last two, BC. Keep in mind, we can figure this out. We can say these are 27, and we know that the two marked are 106, and we can subtract from 180. 180 minus 27 minus 106 is 47, so these two are 47. And we can tell by the angles which side correspond to. Between the 47 degrees and the 106 degrees, right here, is the 28. And it would have to correspond between the same two angles over here, that's the 49. And again, look at y, it's between the 27 and the 47. It would have to correspond with 70, because 70 is between the 27 and the 47. And I already grabbed, I'm going to go back to the same triangle with the y in it and grab that 28, and 28 corresponds with 49. And then we just cross multiply. 49y equals 28 times 70, and divide by 49. Twenty-eight times 70 divided by 49 is 40. Y is 40. Question 27 is a little strange because of the diagram. It's a little bit weird, but this is a good question because it forces you to recognize which angles correspond. And I want to point out that X is in the big triangle. Notice that this angle is in both triangles, angle X. And notice that both triangles have a 90. I have two angles congruent and two triangles because X is in both triangles and the 90 is in both triangles. So these are similar by angle-angle similarity. Since X is in both triangles, it has to correspond with itself. X is first here, X will have to be first there. And I know the 90 corresponds with itself, so I know that Y, the 90, corresponds with N, which is where the 90 is. And the only other point left in the small triangle, X, N, M. So Z and M, those angles, if you can find the ones, they correspond. Now I want to find MN. MN, that's X. All right, MN That's the last two. Corresponds with YZ. Look in the picture, YZ, that's 35. As, go back to the side in the small triangle, because I started with X in the small triangle, I need a side in the small triangle. That's the 6. 6 is XN. I can look at the picture and see that that is the first two, and the first two in this one are XY. And XY, they tell us, is 10. Cross multiply. 10x equals 6 times 35, and we'll divide by 10. Now I'm going to divide these both by 2, and I get 3 and 5. I'm going to divide these both by 5, and I get 1 and 7. I'm left with 3 times 7. X is 21. This last example is the triangle proportionality theorem. When you have a parallel side in there, it divides the sides proportionally. If you wanted to use similar triangles here, that would work. You could say 14 is to it with similar triangles that correspond to that length, which is 34. 14 is the 34. As x in the small triangle is to this side, which is x plus 18. X is to x plus 18. Cross multiply and solve, and you will get x. It works just fine. But this triangle proportionality theorem is a little bit quicker. Because of those parallel sides, I could just say 14 is to 20 as x is to 18. Cross multiply, 20x equals, cross multiply, 14 times 18. We'll divide both sides by 20. It says round to the 10th on this question. Once in a while you get a round, that's one decimal spot. 14 times 18 divided by 20 is 12.6.